dear students, welcome back to physics session. Today we are going to discuss about motion in a plane, important concepts. Yeah, students, you all can download our Spark Academy app. Admissions are open right now. There is a classroom plus online coaching available. Short-term course, crash course, and regular courses are available. So you will be having the daily live classes, in session doubt clarifications, free material in our app with the tips and tricks. Previous discussions will be discussed in the regular sessions. So you can join us for free live classes daily. So join us for regular updates. In a week on Tuesday, my sessions will be on Tuesday and Friday. So students, join us for regular updates. We are having extremely important concept discussions. So ahead, so join with us on Tuesday and Friday. We will be having the physics sessions 11 to 12. Myself, Sandhya. Today we are going to discuss motion in a plane chapter, important concepts and previous year's questions. And if you are buying any course from the Spark Academy app, you can use the coupon. The coupon code you need to enter SAM10. So by using this, you will be supporting me with that. So don't forget to use the coupon code SAM10. So welcome to our session. In our session today, we are going to discuss about projectile motion. From the motion in a plane, projectile motion. In the types of projectile, mainly in this session, we are going to discuss oblique projectile and horizontal projectile. Oblique projectile, horizontal projectile, and one more thing, we have projectile motion on inclined planes that we see in the next session. So today all the important discussions about oblique projectile and horizontal projectile. From the motion in a plane chapter, so you need to solve the questions with the help of the vector algebra. So I hope you all have followed the previous sessions that we have discussed about the vector algebra, how to add the vectors, addition of vectors, subtraction of vectors, and product of vectors we have seen. So by using vector addition, so the concepts in the motion in a plane can be solved by using the vector addition. Resolution of vector into its components. So you need to be thorough with the techniques from the vector about vector addition, resolution of vectors into components. In this mainly you need to check how to find the resultant vector and direction of the vector. So with the help of these techniques from the vector, motion in a plane chapter, especially projectile motion, we can solve the questions. The numericals will be easily solved by using these techniques from the vectors. So vectors play such an important role in the entire mechanics unit, not only in motion in a plane chapter, in the mechanics, where we deal with the motion of the objects, there we can use the techniques of vector. So let us go to our topic. So our concept is, what is motion in a plane or motion in two dimensions? Motion in which the moment of your body is restricted to a plane is called motion in a plane. Let us observe the diagram here. If a body is given an initial velocity, this velocity is a vector, this velocity making angle theta with the horizontal can be resolved into its components. So here we are using the concept of resolution of vectors. So now this velocity resolved into its components. A side which is adjacent to angle u cos theta so this component along the horizontal direction u cos theta, a side which is opposite to the angle u sin theta. Now this velocity is resolving into its components. So motion in a plane or motion in two dimensions, velocity vector and acceleration vector can be resolved into its components. Let us see here. The velocity, it is showing along x direction and it is showing along y direction. So v bar vector can be resolved into its components. Similarly, acceleration also, ax into I cap plus ay into j cap. So yj are the unit vectors along x and y directions. Here vx, vi are the components of v. Similarly, ax, ay are the components of a. So as velocity and acceleration resolving into its components, so we need to describe the motion along x direction, along y direction. So let us see by using the kinematic equations. V is equal to u plus at, s is equal to ud plus half at square, v square minus u square is equal to 2as, and in a interval of time, the displacement in a particular interval of time, having the velocities, initial and final velocities in that particular interval of time, the displacement will be equal to u plus v by 2 into t. These are the standard equations of motion which we have known what we have discussed with the motion in a straight line. So motion in two dimension, you need to describe that motion along x direction, along y direction. Along x direction, we need to give these equations of motion. Along y direction, equations of motion. So with the help of these, we can describe the parameters which are giving about the motion in two dimensions. So let us see x component of motion means this equation can be written Vx is equal to ux plus ax into t. Displacement along x direction, let us take x means ux component into t plus half ax into t square. Next, third equation of motion along x direction, vx square minus ux square is equal to 2ax into x. Next, the displacement in a given interval of time having initial and final velocities, that is ux plus vx by 2 into t. So students, similarly, to describe the two-dimensional motion, we need to give the y component of motion also with the help of these equations. Means you need to take velocity along y direction, means final velocity. Here v refers final velocity and u refers initial velocity. A refers acceleration, t is time. Displacement, s refers displacement. So these all parameters we need to give along x direction, along y direction. So here we are taking components along x direction, that quantities, and as velocity and acceleration both resolving into its components, here we take only x components. Here we take, while describing the motion along y direction, we need to take the components of y along y direction. Means components of velocity and acceleration along y direction. Similarly, displacement along x direction, displacement along y direction. So these equations of motion plays very important role to solve the numericals in 2 dimensions. So you should have idea that as vector and velocity resolving into its components, so we need to describe that motion along x and y. So let us see what is projectile motion. Now our concept is projectile motion. If any object that is given an initial velocity obliquely means which is projected from the ground. See here, it is projected from the ground. It is given an initial velocity u, and that subsequently follows a path determined by a gravitational force. So throughout its journey, it follows the path. Throughout its journey, it is determined by gravitational force. So along y direction, it is determined by that motion of a path is determined by the gravitational force and no other force. Here we need to make a few assumptions. No other force will act while describing the projectile motion. Along vertically, it is determined by the gravitational force. That is very important thing. Acting on it is called projectile motion. Such motion is called projectile motion. So now this velocity, which is given an initial velocity u, resolve into its components, u cos theta, u sin theta. And let us see in the diagram. This is the horizontal distance covered from the point of projection to till it reach the ground, and this is the path taken by the object in its journey. So this horizontal distance is called range. So you can say parabolic path is nothing but vertical motion plus horizontal motion. Vertically, there is component of velocity u cos theta. In horizontal motion, there is a component of velocity u cos theta, and it covers the maximum distance horizontally. So at any instant in its journey, for example, if I take at this point, horizontal component direction is this way, vertical component is like this. If I take at the maximum height of its journey, here also horizontal component velocity direction along x direction and vertical component at the maximum height is 0. Component of velocity vertically 0 at maximum height. But there is component along x direction. And at this point, here also it shows the direction horizontally and there is vertical component. If we observe at any instant in its journey from point of projection to till it reach the ground, at this point vertical component is showing upward, at the maximum height vertical component becomes 0, at this instant vertical component showing downward direction. So it is determined by the gravitational force throughout its journey. So vertically acceleration is equal to g. That too we take minus g, because from the point where the object is projected above that, all the distances or magnitudes will be positive. Below that point from that origin, all will be negative. So it is in the negative direction. So acceleration, it acts vertically downwards, but from the origin it is showing downward, which follows the sign convention negative. So here you can see in this vertical motion, so u sin theta component is acting vertically. Of course, it follows again, it reaches down, which is determined by the gravitational force. So parabolic path is nothing but vertical motion plus horizontal motion. And these 2 points, Horizontally, no change in direction of velocity. Here, here and here you can observe. There is no change in direction of velocity. So, horizontally, it is in uniform motion. So, for uniform motion, acceleration of the object is 0. Vertically, it is determined by the gravitational force. Its direction is changing at every instant in its path. So you can say there is a change in velocity. So parabolic path is nothing but vertical motion plus horizontal motion. So next, our concept is oblique projectile. It is the type of projectile motion. Oblique projectile means projectile thrown from the ground, which is projected from the ground. So you can observe in this diagram an object from the origin O. It is projected, it is given an initial velocity u. As a vector, it resolves into its components. At any other point, the velocity is resolving into its components. By following the vector addition, you can find the resultant velocity. So at this point, and at this point it is making an angle beta with the horizontal. So you can find the direction of vector with the help of parallelogram of vector addition. So we can use the techniques of vectors here. By using parallelogram of vector addition, you can find a resultant. You can find the direction of the vector, and it follows the parabolic path. In its journey, this is the maximum height reached by the particle from the point of projection to till it reaches the maximum height. At this point, there is only x component of velocity, y component is equal to g. At any other point, it resolves into its components. So the resultant velocity can be found by using parallelogram of vector addition. We have known how to find the magnitude of the resultant of two vectors and how to find the direction of the resultant of two vectors. So as it is resolving into its components, we need to give the motion along x-axis. We know that along x direction, at the point of projection, ux is equal to u cos theta, acceleration is 0, and displacement is ux into t plus half ax into t square. So horizontal distance covered will be equal to, put ax value 0 here, then it becomes x is equal to u cos theta into t. This maximum horizontal distance covered is called range. So, and we need to describe motion along y-axis. Along y direction, it is determined by the gravitational force. So, A along y direction will be equal to minus g by following the sign convention. And displacement along y direction, we need to take velocity component along y direction into t plus half ay into t square. Then it becomes u sin theta into t minus, it is minus half because ay is equal to minus g, minus half gt square. So this is the displacement along y direction. Next, and let us see the quantities related to oblique projectile, which are the quite important results to solve the oblique projectile numericals. Time of flight, it is given as 2u sin theta by g. Time of flight means it is the time taken from point of projection to till it reach. Means to complete the projectile motion, what is the time taken? That is called time of flight. So it can be equal to 2u sin theta by g. Means here at the time of flight, Let me say one trick here. When it reaches the ground, it can have only horizontal distance and there is no vertical distance. So we can keep y is equal to 0. Vertical distance is 0 when it reaches the ground. So put y is equal to 0 in equation 2. By putting y equal to 0 in equation 2, we can find the time of flight as 2u sin theta by 0. Next, range. Range of the projectile, which is the horizontal distance covered by the object. Maximum horizontal distance covered by the object. So that range is equal to u square sin 2 theta by g. Means just in equation 1 substitute t value. T means nothing but time of flight value. Then by substituting that we get r is equal to u square sin 2 theta by g. This is the horizontal distance covered, which is called as range. And you need to substitute what is the time taken to cover the distance. So by substituting this value here, we get range is equal to u square sin 2 theta by g. And next, maximum height. Maximum height reached by the object from the point of projection to till that maximum height. At the maximum height means we use the equation at the maximum height Vy is equal to 0. Means by using the equation Vy square is equal minus Uy square is equal to 2Ay into S is nothing but H max. By using this equation, so you need to substitute Uy. Uy is U sin theta. Ay is minus G. U sin theta whole square and Vy is 0. Then the maximum height can be calculated as U square sin square theta by 2G. And next, let us see for maximum range what will be the angle of projection. So for maximum range, angle of projection should be 45. Means when the range will be maximum if sin 2 theta is maximum. Since sin 2 theta will be equal to 1 for theta is equal to 45. So 2 into 45, 90, sin 2 theta will be equal to 1 at this point of, at this angle of projection. Then range will be maximum. What is that range? So substitute sin 2 theta as 1. Then the maximum range is equal to U square by G. Okay. That is the maximum range. Next point. Identical projectiles launched at complementary angles have the same range. So identical projectiles launched at means from the same point objects are projected with the complementary angles. Complementary angles means for theta and 90 minus theta. For example, initial point of projection, initial angle of projection 30 degrees and 60 degrees. So for these angles like this, and next for example 45 and 90 minus 45 is 45. Like these complementary angles of projection, identical projectiles are launched and they have the same range. So for complementary angles, that object can have the, means it can cover the maximum horizontal distance, say for both the angles. The best one you can consider here 30 degrees, 60 degrees. If it is 60, then 90 minus 60 will be 30. That way. So, when identical projectiles can have the same range means at complementary angles like 30, 60, next 60, 30, like 50, 40. So for those angles, range is same. Means you can check by putting the value here. Just one time put 30 and next 60. You will get the range same. Next important equation of a trajectory. Equation of trajectory. Let us see here the vertical distance is u sin theta into t minus half gt square. Here t is nothing but total time taken to reach the ground. So we can substitute here that t from the range. From the range t will be equal to x by u cos theta. Substitute that t value in equation 2. Then we can find equation of the trajectory. Y is equal to x tan theta minus gx square by 2u square cos square theta. So it is in the form of y is equal to ax minus bx square, which is the parabolic path. So here we are saying an object is projected, it follows the parabolic path. The equation of parabola is like ax minus bx square. A is tan theta, b is g by 2u square, g by 2u square cos square theta. So just we are writing this parabolic equation in terms of constants. And the trajectory, equation of the trajectory can also be written as y is equal to x tan theta into 1 minus x by r. So this equation also we can use. And when angle of projection is mentioned, we can find the initial velocity. We can find by using this equation. And when angle of projection is mentioned and the range is mentioned, we can use this parabolic equation. So equation of path is, here equation of path we have shown, it is in the form of parabolic path. And next, finally, velocity at any point. What will be the velocity at any point? Means here, at this point, nothing but instantaneous velocity at the particular point. Or at this point, so it is making angle beta with the horizontal. So velocity at any point means the resultant as it is resolving into its components, v is equal to under root of vx square plus vy square. So let me say here vx is equal to ux plus ax into t. Vy is equal to means velocity after some time, that way. Uy plus ay into t. By using these equations, we can substitute vx square component, vy square component. Then the resultant is being equal to v is equal to under root of u square plus g square t square minus 2gt u sin theta. Means vx component there is only ux will come because ax 0, this part will not be there, and vy component u sin theta, uy value minus gt whole square we expanded here. So this is the velocity at any point, or it is also called as instantaneous velocity. And the instantaneous angle beta with the horizontal. So this is the instantaneous angle with the horizontal beta. So here we are using how to find the direction of the resultant. So take tan beta. It is tan beta which is equal to Vy by Vx, which will be equal to u sin theta. It is u sin theta minus gt by u cos theta. Because Vy is u sin theta minus gt, Vx is u cos theta. With the help of these equations, then it becomes gt by u cos theta. You can write it as like tan theta minus, this can also be written as tan theta minus gt by u cos theta. So students, these are the important results about the oblique projectile which is projected or thrown from the ground. So with the help of these results, you can solve the numericals about the oblique projectile motion. So let us go to horizontal projectile. Next type of the projectile is horizontal projectile. Horizontal projectile means from certain height an object is given with the velocity horizontally. So there is velocity means it is given with the velocity in horizontal direction. So ux is equal to u. There is no uy component. Uy is equal to 0. And after projection, it follows the parabolic path only. Even horizontal projectile also follows the parabolic path. At any point in its journey, for example, at this point, here that velocity resolved into its components. Then this will be the resultant velocity. So here Vx, which will be equal to ux, we can write it as u, and Vy. So after some time, at a particular point, it is determined by the gravitational force. There is no uy initial velocity by using this equation. Vy is equal to uy plus ay into t. So here we can write ay is g, can be written as g. So we can write actually minus, so magnitude is g. So at any point by following parallelogram of vector addition, we can find the resultant velocity and we can find the direction. See here, velocity at any instant will be v bar is equal to vx into I cap plus vy into j cap. So then we can write resultant vx is equal to u, vy is equal to minus gt. So whole square means it becomes u square plus g square t square. If beta is the angle made at that point with the horizontal, then direction of that resultant vector, which is the velocity, can find by using tan component. Tan beta will be equal to Vy by Vx, which is equal to Gt by u, because its magnitude. Next, so when it is given with the horizontal velocity from a certain height, after some time it is resolving into its components. So we need to describe this motion along x-axis, along y-axis. Let us see motion along x-axis. At the point of projection, ux is equal to u, ax is equal to 0. We know that in projectile motion, along x direction, the object moves with the uniform velocity, so acceleration is 0. And displacement along x direction, ux into t plus half ax into t square, then it becomes ux is u, put ax 0, then x is equal to ut will get. This is nothing but range of the horizontal projectile. And what is the time taken means? It will be equal to the horizontal distance by u. Now, similarly we need to describe the motion along y-axis. There is no initial velocity vertically, u by 0, a1 is equal to minus g. Then we can write using equation uy into t plus half a by t square. Y is nothing but this one. See here, this is the point of projection. From here above, the distances or the quantities will be positive. From the origin below, all the quantities are negative. That is why a1 is minus g. So this vertical distance is also let y is equal to minus h. So we can write here minus h is equal to minus half gt square, minus minus cancel. Then the height of the projectile will be equal to half gt square. So this is the height of the tower from where the object is projected. And if you substitute t value, time taken to reach the or to travel that height while reaching ground, so this much time takes. So you can substitute t value here, then it becomes g by 2u square into x square. So it is being like half kx square, which is the mini parabolic equation. So we can say when object is projected from a certain height, that object will also follow the parabolic path. We have proved the equation of the parabola, which is equal to half kx square. In horizontal projectile, what is time of flight and horizontal range? Time of flight is the time taken to reach the ground, from point of projection to till it reach the ground. So under root of 2h by g, and r is equal to u into, means from here we can write time of flight, and range will be equal to, this is the range, so x is equal to u into t. Then t value you can substitute here, and from this t is equal to, in terms of height of projectile we can write, that is the time of flight and range of the horizontal projectile. So these are the important results to solve numericals about horizontal projectile. So all the equations at one place. So students, easily you can solve any question. If they are asking velocity at any instant, what will be velocity at point of projection, and what is the time taken to reach the ground, and what is the horizontal distance covered. So these type of all these questions can be asked. So students, download our app for great discounts on our courses. So in our app there are free handwritten notes, free study materials, previous questions are included, and free mock tests will be conducted. If you are buying any course from the Spark Academy, you can contact these numbers which are given below for admission. So there is a link in description. So admissions are open for the short-term coaching, timings are mentioned for regular coaching, and crash course is also it is coming soon. And students, if you are buying any course from the Spark Academy, apply the coupon code, enter it, coupon code SAN10. By using this, you will get the discount on the course. So in our app you will be having daily and on-demand live sessions. So if you are buying any course or you are joining the Spark Academy, this is our methodology. We will start right from the basic concepts, shortcut methods, all model questions, exercise questions, previous year's questions, chapter-wise tests, weekend tests, grand tests, and test analysis will be given immediately after the exam. So here is the schedule. You can see for the access to the classroom and for online, for books, for grand tests, everything. And let me give you important points. About horizontal projection and oblique. Today in our discussion, we have discussed about oblique projection and horizontal projection. So let us discuss the important points about oblique projection. Oblique projection means an object is projected from the ground. So if they ask what will be the change in velocity and change in momentum and the angular momentum of an oblique projection. So first let us see what is change in velocity at different positions in x path. For that, let me give you initial velocity means at the point of projection. I means initial velocity. It resolves into its components. So u sin theta into I cap plus u sin theta into j cap. It is vertical component, and u cos theta into I cap. And final velocity means we are taking, this is initial velocity at point of projection. It is at the projection, and we take at maximum height what will be the final velocity. We know that vertical component velocity 0 at maximum height, then final velocity is only u cos theta into I cap. No vertical component. And at complete projection, so at complete projection, take these equations 1, and at complete projection we can write final velocity. Actually at the point of projection there is an initial. So at complete projection we take the final velocity. It is u cos theta into I. Horizontal component direction will not change. So while after reaching the maximum height, to reach the ground, vertical component velocity shows downward. So minus u sin theta into j cap. Now we find what is change in velocity. They can ask change in velocity between point of projection to, can write point of projection to maximum height. When it reach max h means maximum height. So you just take change in velocity is nothing but final velocity minus initial velocity. It will be equal to, take these two, difference between these two. Then u cos theta into I minus u cos theta into I, it cancels. And only this component will be there. So it is minus u sin theta into j cap. Magnitude means under root of u sin theta whole square. That's right. So they can ask what is change in velocity between point of projection to maximum height. And next, change in velocity, let me give PT means point between point of projection to complete, when it completes the projection. So when it completes the projection, we need to take change in velocity. So delta U. Now you have to take 3 minus 1, like equation 3 minus equation 1. Here equation 2 minus 1. So it gives U cos theta into I minus U sin theta into J minus U sin theta into J minus U cos theta into I. So negative terms cancels. This minus and this minus, it will become minus 2U sin theta into J. And next, if they ask change in momentum, change in momentum at same cases, between point of projection to maximum height and between point of projection to complete projection, what is the change in momentum? Momentum formula is mass into velocity. You just for these results multiply with the mass. So change in momentum, case A, between point of projection to maximum height, you just multiply here with m, then that is the change in momentum between these two positions, minus mu sin theta into J. It is between, means origin to H max. And next, change in momentum. Next, here also you just multiply with m, it will become minus 2 mu sin theta into J. That is between, origin means point of projection to complete projection, or you can write origin to ground. Complete projection means when it reaches the ground. So you must know the resolution of vector at point of projection to some other point. So by that you can take the change easily. So these are the important points about oblique projection: change in velocity and change in momentum. So let me discuss a few questions related to these concepts. See here, a gun throws a shell with a muzzle speed of 98 meter per second when the elevation is 45 degrees. The range is found to be 900 meters. So it is throws with a speed of 98 meter per second. When the elevation, that angle of projection, it is given as 45 degrees. The range is found to be 900 meters. How much is the range decreased by the air resistance? Means this is the range found when air resistance is there. But in projectile motion, our assumption is no other force acts on it. It is determined with the only gravitational force. So let us find the range by using u square sine 2 theta by g, where u is 98, whole square means into 98. This is without air resistance and it is found to be 900 meters when air resistance. Then you can find, after finding without air resistance, what is the range decreased by the air resistance. So it is found to be decreased when air resistance is there. So just we are substituting sine 2 theta 45, it becomes 19. So it is 1 by 9.8. So 9.8, it can cancels 10 times. So then it is equal to 980. This is without air resistance. So you can say without air resistance. 980. Therefore, you can write it as decrease. What is the decrease? How much it is decrease range by the air resistance means 980 minus 900, which is equal to 80 meters. That is the decrease in range. Next, a particle is projected with velocity u at an angle theta with the horizontal, so that its horizontal range is twice the greatest height attained. The horizontal range is, what will be the horizontal range? They are asking. The given, or they are saying given that horizontal range is twice the maximum height attained. We know that range is equal to u square sine 2 theta by g. Maximum height is equal to u square sine square theta by 2g. And for our convenience, just we are writing it as sine 2 theta as 2 sine theta cos theta. So 2 u square 2 sine theta cos theta by g. Here let it be, and substitute range and height in the given condition. Then this implies 2 u square sine theta cos theta by g is equal to 2 into, given is, it is equal to twice the maximum height. 2 into u square sine square theta by 2g. 2u square cancel, and g cancel, 1 sine theta cancel, take cos theta this side, sine theta by cos theta is tan theta, take 2 this side, we are getting tan theta is equal to 2. So tan theta is nothing but opposite side by adjacent side. Hence, we can write from the trigonometric ratios with this value, sin theta will be equal to 2 by root 5. Cos theta will be equal to 1 by root 5. Okay. Now, they are asking the horizontal ranges. With this condition, what will be the horizontal range? Now, substitute sin theta, cos theta values here from this equation. Range will be equal to 2 u square into by g also into sin theta is 2 by root 5, cos theta is 1 by root 5. Then it becomes 4 u square by root 5 into root 5 is 5. So it will be 4 u square by 5g. This option is correct. Next, a staircase contains 3 steps, each 10 cm height and 20 cm wide. What should be the minimum horizontal velocity of a ball rolling off the uppermost plane so as to hit directly the lowest plane? This is the uppermost plane. It hits, let us say uppermost plane at this point A. 2, it hits the lowest plane, not the ground, lowest plane. So when it hits the lowest plane, it covers 2 steps. It should be covered 2 steps height and width. Height of the each step and wide height is given 10 cm and wide is given 20 cm. Wide is nothing but range. Now tell me what will be the total range when it hits the lowest plane. So 2 into this wide. So 2 into 20 centimeter, 40. It is in centimeter. It can be written as 0.4 meters. And what is the height of the projectile? So here also it covers. H is also 2 into 10 centimeters. Means not till ground. We need to take uppermost plane to directly to the lowest plane. So this height only you need to consider. So that is what it covers. 2 steps the height. It travels 2 steps height. So 20 centimeter, which will be equal to 0.2 meters. Now they are asking what should be the minimum horizontal velocity of a ball rolling off the uppermost plane to hit the directly lowest plane. It is looking like a horizontal projectile. So horizontal projectile, height of the projectile is half g t square, and t is equal to x by u, nothing but range. So substitute, since t is equal to x by u, we can write it as half g into, whereas x is nothing but horizontal range. So it will be equal to r square by u square. That is height of projectile. So from this we need to find initial minimum horizontal velocity. Here what is it is given with the velocity. So u square will be equal to g r square by h. Then I can write it as half into g value, take it as 10 meter per second into r square is 0.4 into 0.4 by h value it is 0.2. So 0.2. 2 into 0.2 and it cancels 0.4. So 10 into 0.4 will be equal to 4. That is u square value. So u square is equal to 4. U is equal to under root 4. So at the topmost plane or uppermost plane, it is given with the horizontal velocity 2 meter per second. So with the help of horizontal projectile, we have solved this equation. Question. Next, if retardation produced by air resistance to the projectile is 1/10 of the acceleration due to gravity, the time to return from the maximum height. If we observe that the oblique projectile, to reach the maximum height, the time taken is time of ascent. So it travels this vertical distance, and to reach the ground, it travels the same vertical distance. So the time taken is time of descent. So time of ascent, time of descent is same. So that is when it makes angle theta with the horizontal, you can say u sin theta by g. From this total time means we write it as 2u sin theta by g. So they are asking the time to return from the maximum height. And they are saying that retardation produced by the air resistance. So let us take these two times are equal. Let me give you T. When it is reaches to maximum height or to reach the ground from the maximum height, magnitude is same, time taken is same. So T is equal to u sin theta by retardation produced by air resistance is 1/10 of the acceleration due to gravity. So it can be written as g minus g by 10. Means it is reduced. So we can say it as u sin theta by, if you take LCM, we get 9g by 10. It becomes 10 will go up. So we can write 10 by 9 into g. So it is, so when there is a air resistance, let me say it is T dash and this is T. So it is 10 by 9 times of initial time period. Then what is they given options like it increases or decreases. They are in percentage. So if you take percentage increase in time, we need to write delta T by T value. So take this is T, take this side, delta T by T will be equal to 10 by 9 minus 1, which is equal to 1 by into 100. When we are taking percentage, we multiply with 100. So 1 by 9 into 100 is 100 by 9, which is equal to 11.1 something will come. So it is taken as 11%. So students, in today's session, this is the required discussion about oblique projectile motion and horizontal projectile. Here I given a few previous days questions also. You can try with the results and you can drop your message in the chat. See, you can solve these questions along with those two. You can try these questions also and post your answers in the comments. So students, thank you, and we will be having extremely important concept discussions ahead. So join with us for regular updates. Thank you.